Hello everyone, I'm going to show you guys how to draw a Origin graph using the Origin Pro program. To start off, I'll first draw a PXRD graph. When you guys use the PXRD instrument, there will be a total of 3 files. You should ignore this text file, ASC, which is called ASCII, RAS file, and the raw file will come out of the computer. You can change the ASCII file into a text file and then simply insert it into this bar. So it'll appear like this. And in order to draw a PXRD graph, you can double click the x-axis and the y-axis and this will turn black. And at the bottom left corner, there's an option called line. When you click it, the graph will automatically be made. You can render minor stuff such as turning this into MOF5 and changing the y-axis into intensity. Our school's PXRD diffractometer, which is located in Changjo-1 6th floor, has the dimension of counts per second, in short CPS. So you could insert that in the y-axis. And the x-axis, you should write degree and 2 theta. In order to input the theta symbol, you can right click the cursor and there will be this symbol map. You can find the theta symbol and double click it and it'll be inserted. Yep. So it's done right now. And from this graph you can assume that the material that I synthesized is amorphous, which is the opposite of a crystalline material. I'll show you how to make a multi-layer PXRD graph. These data are the ones that are made with zinc acetate as a metal salt and an 4,4-oxybis benzoic acid as a ligand. We tested if they are stable in water in a 10-minute interval. And we made a total of 6 PXRD graphs, and now we're going to put them in one graph and see if their intensity has decreased over time. As I told you earlier, 3 files are made: RAS, ASC, RAW. Using ASCII file and transferring them into text file is the most commonly used, but I didn't know that common fact. I knew it just today by Mrs. Choi. And this is how I kept my data. I used the data rendering using the RAS file, and I'll just copy these 2. So this will be the initial data, and we need to add multiple columns in order for the 10-minute graph, 20-minute graph, 30, 40, and 50 to all fit in one. Now you can see that I completed the whole process. In some cases, like using DSC or TGA graphs, the x variables are different in every analysis, so you cannot just make them all into one x-axis and the rest all y. But in this case, you can see that all the x-axis of the PXRD graph are the same because we programmed it to increase 0.02 degrees. So in order to make a simpler version, you can select all of these and move to this. Stacked lines by y offsets. Yep, and this now appears. And you can change this to intensity CPS, this to degree 2 theta, and these. You can also like label them. And delete it. And this might be even better. Like this. And change the scale to from 3 to 50 or 5 to 50, anything is fine. Because it's a MOF. Yep, and this is the end of the PXRD stacking. So this is the Mercury software in which you can attain the Powder XRD data. In order to do that, you can either import the file which is already in the CCDC database, or if not, you can import files from other software such as the Material Studio program, which is also located in Chang 610. I'll import the zinc oxide structure. Yep. And this 3D image will appear. And if you click this powder in the bottom on the center part, the XRD graph will be calculated automatically. But here's one thing. In the case of metal oxides, you need to get the graph between 10 degrees and 80 degrees, unlike normal MOFs, which is between 3 to 50 degrees. You need to customize and click the pattern, and you can render the starting degree and the ending degree. And click apply, and it will change like this. You can save this graph like with the data file like this with the form XYE. Now we will move on to merging the graphs. Once you've synthesized a material, you need to check if it's the right material that you desire. In order to confirm that, you need to bring a simulated PXRD data and compare it with your synthesized data and merge the graphs and find if the peaks are located in the same location. So I brought an zinc oxide PXRD data just for an example. And to show you a tip, if you write something in the comment section and make a graph out of it, it'll appear in this bar. Yeah, so that was just a small tip. Before you initiate the Control V, when you right click the blank space of the origin, add new column, this thing appears. So repeat that twice. And yep, this will appear. And I'll write zinc oxide simulated. In ordinary cases, however, the simulated data should be at the most bottom, so that the actual zinc oxide that we synthesized can be compared based on that. So we will change these two bars. We changed the sequence. And did you notice that all the A, B, C, D lines are representing the y-axis? We also need to change it. If you just ordinarily tap at the top, this symbol will appear. And if you click this, this will change into the x-axis. And if you click this as well, it'll change into the x2 axis. So this is it for now. And in order to merge the two graphs, you need to first make two separate graphs of the simulated zinc oxide and the actual zinc oxide. So only select these two lines and draw the graph. So this is the simulated one, graph 1. And when you go back to this and select these two and make one graph out of it, it will be the actual zinc oxide that you synthesized. In order to merge these two graphs, you should click the graph at the top left corner and merge graph windows and move on to the open dialog. You can choose what two graphs to merge, so in this case graph 1 and graph 2 will be it, and in order for them to be in one single graph, you need to change this number of rows and number of columns both to 1. And this is the preview at the top right. You can see that the peaks are in the same location. If you click OK, this will appear, and if you want to make it more clear, you can either change the colors to red. You can see that this process is successful. In order to make the graph look a bit cleaner, it's okay to delete the y-axis itself, because the intensity isn't normalized and there's no point in measuring the relative intensity of these two graphs. And the x-axis will be degree to theta as always. And it's best for you if you change the scale so that it fits exactly the left and right. If you click OK, and also for this too. And it's okay to make the graph like this, but if you want it to be a bit more clearer, you can always choose to change the thickness of the graph. If you click 1, it will be even more thicker, and if you choose 1 for this, you can left click and change it to 1. They will both be more clear. And you can either leave it like this or to change it. There's also a label function which makes attached to plots, and you can always change the location and where you will put the label. For me personally, this takes up less space when you make the graph, so I use this more often. And change it to here, and if you delete this, this is another way to make a good graph.